is equal to f of x.
Thanks.
So we could say f of x is equal to x squared minus 3x plus 2. So again, x is a symmetry. X is equal to negative b over 2a. So I'm just going to steal the work from over here. Or the writing, anyway. I already had the of. All right, quick substitutions. All right, the b value is negative 3. The a value is an understood 1. All right, so x is going to be equal to negative parentheses over 2 times parentheses. All right, so negative 3 over 2 times a positive 1, that's going to give us 3 halves. All right, so that's a little different. All right, so we got to be able to sort of maneuver around that. So make a table of values. Again, x against f of x. But this time, 3 halves has to go in the middle. All right, we still want integer values, 3 consecutive integer values that are less than the axis of symmetry, and 3 consecutive integer values that are greater than the axis of symmetry. All right, so if you think of a number line, and I'll actually just draw one real quick. I'll just kind of chuck it in over here. Just a quick number line, nothing too crazy. All right, so you have, I'll do negative 1, 0, 1, 2, 3, for example. You know, just a little bit. All right, 3 halves in decimal form is 1.5. So that would put it right here. So 3 halves. I want the 3 consecutive integers that are less than 3 halves. So that means I want the 1, the 0, and the negative 1. All right. So 1, 0, negative 1. All right. A common misconception that people have, and you know, it's not terrible. It's not really wrong even, is that people will take that 3 halves and subtract 1 from it and get 1 half, then subtract 1 and get negative 1 half, then subtract 1 again and get negative 1.5. That's not wrong. You just gave yourself a terrible set of values to work with, because now you have decimal values that you have to plot, and they're probably going to coincide with even more decimal values on the y, or for the y values, right? Making things more complicated, right? Whereas if you work with the integer values, things tend to be a little nicer, all right? So on the high side, we would have the 3 consecutive integers beyond 3 halves would be 2, 3, and 4. So 2, 3, and 4. All right. So we're always looking for the integer values, consecutive integer values to the left and to the right on the number line, less than, greater than, if you're just considering it, than whatever the vertex value or the axis of symmetry value is. All right, then those numbers go into the table, or they'll be in the table once you type in your equation. All right, so that's where this comes into play. So y equals, I need x squared minus 3x plus 2. I'm going to hit second graph. I got a nice table here. A lot of these numbers are irrelevant. The only ones I care about are the ones going from negative 1 to 4. All right, so that would be 6, 2, 0. You don't see the 3 over 2 there, so we gotta handle that in a sec. And then 0, 2, 6 on the other side. You can't just have this mentality of like, well, it's not in the table of values, so I don't have to worry about it. Well, no, you got to account for the vertex. It's one of the most important points on the graph. All right, so to do that, we need another approach. All right, so one way to handle it is the way we talked about yesterday, and that is direct substitution. Take the 3 over 2 and replace all the x's in your original function with 3/2 and simplify. It's kind of, tedious, for lack of a better term. The calculator will do it for you, so that's nice. Right? So the way the calculator, well, one of the many ways the calculator will do it for you would be using the alpha trace button. So alpha trace, you bring up y1. So let me get out of here. Hit alpha trace, select y1, and then type in parentheses whatever the number is you want to plug in. Right? So you would put in parentheses, so it would be y1 parentheses 3/2. And what that'll do is it'll evaluate whatever you have in y1 with the x value of 3/2. So I have this equation, x squared minus 3x plus 2, stored into y1. It's going to replace all the x's in that equation with 3/2. And what this actually means is that you could actually, if you wanted to, you could use this approach to figure out all the y values corresponding with the given x's. So -1, 0, 1, 2, 3, and 4. You could have done y1 of -1 and gotten the 6. I'll show you. Alpha trace y1. You type in -1, it's going to give you the 6. All right, but then you'd have to do that 7 times. I'd rather get most of the values from the table and then just use this one skill to come up with the vertex for the funky situation. Most of the time you're not going to have a fractional value for the vertex, so I wouldn't have to worry about it. But in the off chance that I do, alpha trace y1, type in the x value, and this works to evaluate any function. I typed it in wrong. Alpha trace y1, parentheses 3/2, close it up, and you get your -0.25. Decimal value, I mean, most of the time I kind of shy away from the decimal values. I usually encourage fraction form, but this is one of the instances where I actually prefer the decimal value, because we have to plot these points on a graph. It's easier to see that, where a decimal point falls on the graph than where a fraction does. All right, but when it comes to plotting the points, -1, 6, that should be the easy part. 0, 2, 1, 0, 3/2, so 1.5. So 1.5 boxes over, 1/4 of a box down, so just kind of like a smidge below. Then 2, 0, 3, 2, and 4, 6. Smooth curve through all the points. All right, and just get a label on it. All right, and that would be your graph. All right, so there's a lot going on with this stuff, but it's manageable if you practice, which is why we're spending so much time with this. When you think about how much time we've spent on quadratics, it's been a lot. It's almost been all of 2022 so far. All right, that's how important this stuff is. So we want to spend the time. We want to learn it well. All right, it'll help you in the future, I promise.